Greetings, future scientists and space explorers. Welcome to a journey that will take us beyond the boundaries of our planet and into the vast expanse of the cosmos. When you think of space, what comes to mind? You probably picture giant rockets, towering launch pads, and the sheer power it takes to escape Earth's gravity. These colossal machines have long been the symbol of our ambition to explore the universe. And massive satellites. These technological behemoths, bristling with antennas and solar panels, silently orbit our planet, providing essential communication, navigation, and observation services. But the rules are changing. The traditional image of space exploration, dominated by governments and large corporations, is undergoing a dramatic transformation. Space is becoming easier. Access to the final frontier is no longer limited to a select few. New technologies and innovative approaches are democratizing space, making it more accessible than ever before. Cheaper. The cost of launching and operating satellites has plummeted, opening up opportunities for smaller organizations and even individuals to participate in space activities, and faster to access. The development and deployment of space technologies are accelerating at an unprecedented pace, allowing for quicker turnaround times and more frequent missions. All thanks to something small. This revolution is being driven by miniaturization, the art of packing incredible functionality into incredibly small packages. We're in a new era, a golden age of space exploration where innovation and accessibility are reshaping our understanding of what's possible. Where some of the most exciting things in orbit, the groundbreaking discoveries and innovative applications, are done by satellites you can hold in your hand. These tiny spacecraft are transforming the way we explore and utilize space. These are nanosatellites, also known as CubeSats. Compact, powerful, and accessible to almost everyone. They represent a paradigm shift in space technology, making it more affordable, versatile, and readily available. They're making space more democratic, breaking down barriers and empowering individuals and organizations from all corners of the globe to participate in space exploration and development. Letting students from universities and even high schools design, build, and launch their own satellites, gaining invaluable hands-on experience in space engineering. Startups with limited resources but boundless ambition develop innovative space-based solutions, disrupting traditional industries and creating new opportunities. And developing nations reach for the stars, using nanosatellites to address critical challenges in areas such as agriculture, disaster management, and environmental monitoring. Imagine your school launching its own satellite, a project that would inspire students, foster innovation, and provide real-world learning experiences. Or a small company tracking wildlife from space, using satellite data to protect endangered species and conserve our planet's biodiversity. These tiny marvels are already up there, silently circling our planet, performing a wide range of tasks that benefit humanity. Taking pictures, capturing stunning images of Earth, providing valuable data for environmental monitoring, urban planning, and disaster response. Beaming down data, transmitting vital information to researchers, policymakers, and communities around the world, enabling informed decision-making and effective action, and running experiments, conducting cutting-edge research in microgravity, exploring new frontiers in medicine, materials science, and fundamental physics. So, get ready to shrink your expectations and expand your mind. Prepare to be amazed by the incredible capabilities of these miniature spacecraft. We're about to explore these miniature wonders, delving into the technology, applications, and the people who are making this space revolution a reality. Let's get started, as we embark on this exciting journey to discover the power of small in the vastness of space. Because science is awesome, and space is for everyone. The future of space exploration is bright, and it's being shaped by these tiny satellites and the people who dream big. So what exactly is a nanosatellite? What makes it different from other satellites orbiting our planet? These miniature marvels are changing the way we explore space, making it more accessible and affordable than ever before. In simple terms, it's any artificial satellite weighing between 1 and 10 kilograms. That's the defining characteristic that puts it in the nano category. To give you a better idea, that's lighter than a house cat. Imagine a satellite that weighs less than your furry friend. It's quite remarkable when you think about it. But the real game changer in the world of nanosatellites is the CubeSat. This standardized design has revolutionized the industry. A CubeSat is essentially a standardized cube, precisely 10 centimeters on each side. This uniform size allows for easy integration and deployment. That's about the size of a Rubik's Cube. a familiar object to help you visualize its compact dimensions. But here's where it gets interesting. These cubes can be stacked. This modular design allows for customization and scalability. For example, 3 units stacked together create what's known as a 3U CubeSat, roughly the size of a loaf of bread, and 6 units, a 6U CubeSat, is about the size of a small briefcase. This flexibility in size allows for a wide range of mission capabilities. This modularity is a huge advantage, giving engineers incredible flexibility in designing and building satellites for specific purposes. Furthermore, standardized parts mean faster, easier builds. This reduces development time and lowers the overall cost of missions. Think of it like Lego bricks for space. You can easily snap together different components to create a functional satellite. Nanosatellites, and CubeSats in particular, are essentially small, lightweight boxes packed with cutting-edge technology. They're designed for focused tasks, such as capturing high-resolution images of Earth, or relaying communication signals across the globe. They're a testament to the fact that powerful ideas and groundbreaking innovations can indeed come in tiny packages. So when you hear the term CubeSat, think of stackable cubes that are making space accessible to universities, research institutions, and even private companies. Ultimately, it's not the size of the satellite in orbit that matters most, but the size of the scientific discoveries and technological advancements it enables. Because sometimes, the smallest packages truly do deliver the biggest impact, pushing the boundaries of what's possible in space exploration. What can something the size of a coffee mug do in space? A lot. Nanosatellites are key for Earth observation, monitoring forests, ice caps, and crops with swarms of tiny photographers in the sky. They're revolutionizing communications, connecting remote villages, ships, and planes with global networks of small satellites. If one fails, another takes over, making the system resilient and widespread. Universities use them for experiments, from studying Earth's magnetic field to testing new tech in space. They help track space debris, keeping orbits safe. Governments use them for secure communications and surveillance, thanks to their flexibility and quick launch times. From farming to national security, these tiny titans are changing our world. It's amazing what a little box of circuits can do from hundreds of miles up. Nanosatellites are the ultimate multi-tools of the cosmos. Why is everyone excited about nanosatellites? The biggest reason? Cost. Traditional satellites cost hundreds of millions. Nanosatellites are dramatically cheaper, using off-the-shelf parts. This puts space within reach for small organizations and schools. Speed is another advantage. CubeSats can go from idea to launch in a year or two, using the latest tech. With lower costs, teams can take risks, try bold ideas, and learn fast from failures. The standardized CubeSat design has created a global ecosystem of parts and suppliers. Teams can focus on their unique mission, not reinventing the basics. Low-cost, rapid development, and plug-and-play design make nanosatellites the smart choice for modern space missions. It's a new, dynamic way to explore space. The nanosatellite revolution is about innovation, not just miniaturization. Space is now open to more dreamers than ever. The new space race isn't just between superpowers, it's global. The US leads with companies like Planet Labs and Spire Global, plus NASA and the military. China is rapidly building its own nanosatellite capabilities, launching for research and communications. Russia, Europe, and Japan are all major players, with universities and agencies pushing the boundaries. Japan, for example, pioneered the CubeSat and leads in space debris solutions. India offers affordable launches, and countries across South America, Africa, and Southeast Asia are joining in. Nanosatellites have let dozens of nations launch their first satellites. This is a worldwide collaboration, not just a race. Now every nation can participate and contribute to our understanding of the cosmos. Space, once the exclusive domain of governments and massive corporations, is now becoming increasingly accessible. But how much does it really cost to launch a nanosatellite and participate in this new space race? Let's break down the costs associated with sending your own small satellite into orbit. Building a simple CubeSat, the standardized small satellite, can be surprisingly affordable. The basic components and assembly can be as low as $50,000. That's about the price of a new car, maybe even a well-equipped SUV. It's a far cry from the tens or hundreds of millions previously required for space access. Of course, the capabilities of your satellite will impact the price. More advanced models, equipped with high-resolution cameras or sophisticated scientific gear for conducting experiments in orbit, can cost significantly more, potentially reaching up to a few $1 million. But even at that higher price point, it's still a bargain compared to the cost of designing, building, and launching traditional, full-size satellites, which can easily run into the hundreds of millions or even billions of dollars. Launching used to be the single biggest barrier to entry in the space industry, representing the vast majority of the overall cost. But now, thanks to innovative launch strategies, nanosatellites can ride-share on rockets, hitching a ride alongside larger payloads. Think of it like carpooling to space, splitting the cost of the launch among multiple passengers. Securing a launch slot for a standard CubeSat can now cost in the range of $40,000 to $60,000, a fraction of what it used to be. This means that a university project, from initial design to final deployment in orbit, could potentially reach space for under $100,000 total, making it an accessible and exciting opportunity for students. Of course, commercial missions, with their more stringent requirements and complex operations, might run a few $1,000,000 from start to finish, encompassing everything from development and testing to launch and ongoing operations. But even these costs are significantly lower than traditional space endeavors, and these reduced prices have opened space to a new generation of innovators, entrepreneurs, and researchers. With more people gaining access, more ideas are being generated, leading to breakthroughs and novel applications. Consequently, more experiments, technologies, and services are reaching orbit than ever before, expanding our understanding of the universe and benefiting life on Earth. This democratization of space, driven by lower costs and increased accessibility, is fueling a revolution across various sectors, from communications and Earth observation to scientific research and technology development. Ultimately, investing in nanosatellites and the technologies they enable is investing in our future, paving the way for new discoveries, economic opportunities, and a more connected world. Every mission ends, and nanosatellites usually last a few months to a few years. When their mission is over, we can't just leave them in orbit. They'd become space junk. Most nanosatellites in low orbits naturally fall back to Earth, burning up harmlessly in the atmosphere. This process, called orbital decay, turns them into brief shooting stars. International guidelines require satellites to deorbit within 25 years. For higher orbits, engineers are adding tiny thrusters or drag sails to speed up re-entry. Some even imagine space tugs to clean up old satellites. Managing end-of-life is crucial for keeping space safe and open. Responsible planning ensures future generations can keep exploring. The nanosatellite revolution is just beginning. Miniaturization is packing more power into smaller boxes, better solar panels, processors, and batteries. Tiny propulsion systems will let CubeSats maneuver and fly in formation, opening new science possibilities. Swarms of nanosatellites could work together as virtual telescopes or 3D weather monitors. Artificial intelligence will make satellites smarter, letting them make decisions and fix problems on their own. Some will go beyond Earth. NASA has already sent CubeSats to Mars. Fleets of tiny explorers could visit asteroids, moons, or even interstellar space. Cheap, risk-tolerant missions mean we can try bold new ideas. The future of space will be shaped by these small, intelligent pioneers. From humble beginnings, nanosatellites have transformed our access to space. They're not just smaller satellites. They're a new way of thinking, fast, affordable, and open to all. Now, student startups and emerging nations can join the adventure of discovery. Nanosatellites watch over Earth, connect the world, and push the boundaries of science. Their low cost and quick development let teams take risks and innovate faster than ever. The story of nanosatellites proves that great things come in small packages. Technology will keep advancing, sending these tiny explorers farther than ever. Most importantly, nanosatellites have opened the door for you. Your ideas could shape the next space mission. So keep dreaming big or small. The cosmos is waiting. The cosmos,